Hello, Geometry Concepts, folks. This is Mr. Heron. I apologize for being absent today, but hopefully you are able to follow along with the notes and pay attention and still have an understanding. And then I can check and answer questions tomorrow and answer any final questions and check in your homework from both 5.2 and 5.3. I'll check in that homework tomorrow. Let's see, not really any announcements. I'll answer questions tomorrow real quick. Next Wednesday is the last day to check in anything for Unit 4. I'll turn in the assignment tomorrow, but let's look at Unit at 5.3. If you recall, similar. Similar means angles are congruent, sides in proportion. Okay, proportion just means that, the fractions match. Okay, the fractions match. So, kind of like when we had congruent triangles, now we have similar triangles. And there's a couple different ways we can solve that. So, one of them is angle, 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 or sometimes just called angle, angle. And all this says is that if I've got two triangles, and I can show, this one's congruent to this one's congruent to this one, and this one's congruent to this one, or just any two of those, then if that is true, then I can say, yes, ABC triangle is similar to triangle XYZ. Okay, but only if I can prove this. Only if I can show this by markings, or I can prove it by examples, or I can prove it by any of the information from the triangles. Okay, now side, 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 and some of this might look familiar to you. Side, side, side was one that came with triangle congruence. I don't know if you remember that, but triangle congruence, when triangles were congruent to each other, equal to each other. Now we're saying they're similar, but this is all sides. So now sides aren't congruent anymore. Sides are now in proportion. Okay, so sides are now in proportion. So that means that if I've got like A over B, C over D, E over F, that all of these sides will be in proportion, and they'll all simplify to that same fraction. It should, we did kind of an example on that yesterday in the notes, so you can go back and look there. All of these need to simplify down to an equivalent fraction, okay? So, but all these sides need to be in proportion to each other. So the fractions need to match up, okay? So one, side angle, side similarity. This one gets a little tricky for people because the angles are congruent, sides are proportional. And you also have to look for, it's the angle in between two sides. Okay, angle in between two sides. So I'll show you an example of what it looks like, and then I'll show you an example of what it doesn't look like. So here's kind of an example of, yes, this one works. So if I've got two triangles, and I say, hey, those two angles are congruent, then I say, okay, that's A, that's B, that's X, that's Y. Then I say, let's call this R, S, T, and I'll call this one L and E. If I can say, angle S is congruent to angle N, and I can say A over X is equal to B over Y. So I need this and this to be true. Then I can say, yeah, triangle RST similar to triangle LNE. Okay, now what kids get screwed up on, or what kids get twisted up on, is this. Is if I've got a situation where, a similar situation, go A, B, C, X, Y, Z. Is if I've got a situation where I say, like, okay, angle A congruent to angle X, But then we'll call this one R, call that one S, call that one T, call that one N. If I say R over T and S over N, if those are equal, and I say angle A is congruent to angle X, that all might be true. That doesn't make them similar, okay? Because where's the angle located? Okay, the angle would have to be in between the two sides. So these are my two sides that I'm dealing with, okay? So I would need this angle in here, and I don't have that. Okay, and I can show you kind of why that doesn't work in a more formal proof if you want to, but that's kind of the nuts and bolts of it. So 3 ways: all angles, all sides, now an angle in between two. So now if I take a look, let's look. Well, right now B matches up to D. Okay, we know this one 80 is 80. We know this one's 58. So I need to figure out these third angles. So I need to take minus 42, minus 58. So that will give me an answer of 80. So by default, that will give me an answer of 58. So I'm going to say yes, okay, by angle, angle, angle. If I look, I have all my angles. I know nothing about the sides, but I don't need to. So I need triangle ABC. Similar to triangle E. Be careful here. EBF. Okay, all the angles, these things need to correspond. Okay. A B C E D F. Sorry, DF. And then C matches up to F. Those all need to correspond, but it's by angle, angle, angle. Okay, so here, right now on the surface, nothing told about the angles, nothing told about the sides, but arrows mean parallel lines. And parallel lines, we know a lot about, okay? So parallel lines tell me a lot, and I'm going to use the fact that these two lines are parallel to tell me, you know what? P is going to be parallel to, or P is going to be congruent to M. Q is going to be congruent to N, and this one, angle PXQ, is going to be congruent to angle MXN. Why does this one work? Well, these are just vertical angles. Those are vertical angles. Those are always going to be congruent. That's going way back to like Unit 1 stuff. That's absolutely going to always be true forever. And the other ones, why does that work? Well, if you consider parallel lines cut by a different line, then you have to realize that, you know, these two would be alternate interior. Those are going to be congruent. Okay? So that carries over to these two and to these two. All I'm doing is putting in some extra lines. So this one's going to be yes, again, by all angles. And I can say triangle PXQ is similar to triangle MXN. And again, make sure that those points correspond, match up, okay? P matches up to M, X matches up to X, Q matches up to N. Okay. So far, I hope we're doing okay. If you missed something, feel free to pause, back up, and go again. So now, for likewise here, I've got all sides. All sides. So I kind of start to look at, that's my shortest side, that's my shortest side. So I'll look at 4 over 6. That's my next biggest side, that's my next biggest side. I'll look at 5 and 7.5. Biggest side, 6 over 9. Now I'll look at these and see if they all simplify to the same thing. Okay, 4 over 6 is 2/3. That is also 2/3. That is also 2/3. Okay, and as in decimal form, it'd be 0.6 repeating. Okay, so if you threw that in a calculator, you should know that all three of them are going to get 0.6 repeating. So I'm going to say yes, but this is by side, side, side. By side, side, side. So if I said all three sides are in proportion, which I've got, then I can say triangle, and I'll start with ABC. It doesn't really matter how you start as long as you match up correctly. So ABC is going to match up to, let's see, A is going to match up to, let's see, that's going to match up to D. B matches up to E, and C matches up to C. Okay, how do I know that worked up? Well, A is between shortest and biggest. D is between shortest and biggest. B is between biggest and middle. E is between biggest and middle. That's kind of how I know where they are. Okay, so this one's a little bit of a trick because I have to consider this as two triangles. I have M, N, and P, where that is 10 and 12. Then I've got the much, much larger triangle. That's M. This entire thing would be 25. This entire thing would be 30. So now I don't know anything about this side or this side, and I don't need to. I don't really care because M is part of both triangles. Okay, M is part of both triangles. So that's going to obviously be the same. That's going to be congruent. All right, you're equal to yourself. They call that the reflexive property. So that one's true. So now I got to look, is 10 over 25 the same thing as 12 over 30? Okay, because this is a side angle side situation. So I've got side, side, the angle in between, side, side. So is this equal? Let's see, if I divide that, that's 2/5. Divide that by 6, that is going to be 2/5. And that checks. That checks out. So I'm going to say yes by SAS, and I'm going to say triangle MNP is going to be congruent, or not congruent, similar to triangle MRS. And again, these points correspond. Okay. So now these are parallel, find RQ, find QT. So I need to kind of figure out what X is. So first off, I know these are congruent, and I know these are similar because, you know, this is kind of similar to that one we did. I think it was like one of the first ones. These two are parallel. So I know 4 matches up to 10, and I know X plus 3 matches up to 2X plus 10. Okay, that's kind of how they match up. So now, using cross products, distribute 8x plus 40 equals 10x plus 30. Minus 8x minus 8x minus 30 minus 30. 10 equals 2x. X equals 5, but that doesn't answer the question. Okay, they want RQ and QT. So RQ is equal to 8. QT is going to be 2 times 5 plus 10. So that's going to be 20 for an answer. Okay, so I noticed I went, that'd be my kind of my scale factor, 2/5 or 4/10, so it simplifies to 2/5. And then that gets set up equally to x plus 3 over 2x plus 10. And that's my answer. That's my answer. Okay. Sears Tower. Wow, Sears Tower, really, really tall. So we have our tower. Here's like the antenna thing. It casts a 242-foot shadow. Shadows are on the ground, in case you didn't know that. At the same time, a 12-foot lamppost casts a shadow that is 2 feet long. Okay. What is the height of the Sears Tower? Okay, so we're assuming that, okay, they're both right triangles. Okay, we're assuming that they're at the same time, so I can call the triangles similar. So now I'm going to use kind of this fact that, hey, these are both 90. So 242 over 2, okay, these are the shadows, equals x over 12, okay? And this is the heights. All right, the bottom ones, these two, these two numbers are for the lamp, and the top two are for the tower. Okay, you want to keep the same thing, the same thing. So, I did not leave myself any room to do this one. So I'll kind of go over here. So if I take 242 times 12, that will equal 2x. So 242 times 12, you can do a little calculator mashing and get that. 242 times 12 is going to be 2904 divided by 2, 1,452 feet. So how tall is the tower? The tower is going to be 1,452 feet tall. There's my answer. Okay. Okay, so once you are done with this, you need to go up and show that the notes are done, and then you should be able to get the assignment, and you can work on that, and we'll answer questions about that tomorrow. Thank you.